Hello. Last time you'll recall that we started talking about the concept of the mole. And we basically said a mole is just a big number, specifically this number, 6.022 times 10 to the 23rd. The reason that was invented is to allow people to go between atoms and moles, or molecules and moles. Let's do a very simple example to show this with the following combustion reaction. If we take some CH4 gas, specifically 1 molecule's worth, we can react that with 2 molecules of oxygen gas to give 1 molecule of CO2 gas plus 2 molecules of water, which at room temperature, under these high combustion conditions, is a gas as well. We could also say that if you had a dozen molecules of methane, you could react that with 2 dozen molecules of oxygen to give a dozen CO2 molecules and 2 dozen water molecules. Or I could use this ratio as well. 1 mole reacts with 2 moles to give 1 mole and 2 moles. And this is what I want to be able to do, though, is convert that to atoms or molecules. So we know 1 mole is this many, in this case molecules of methane, reacts with this many molecules of oxygen to give this many CO2 molecules and this many water molecules. So I simply converted moles to numbers of atoms, or molecules in this case. So let's kind of use that in some simple problem solving here. Let's say I want to know how many silver atoms are there if you had 2.54 moles worth of silver atoms. Well, clearly this is your given. So we have 2.54 moles of silver atoms. Well, I want to know how many actual atoms of silver is that. So when I know from unit analysis I have to cancel out this mole, I know that 1 mole of silver atoms for that many 1 mole of anything is 6.022 times 10 to the 23rd silver atoms. So my units cancel, and I know that I have 1.53 times 10 to the 24th silver atoms. 3 sig figs. Well, this makes a lot of sense. You know that 1 mole is this many atoms, but I don't have 1 mole. I have 2.54 moles. So simply take these two numbers and multiply them together to tell you how many atoms of silver you have. I could go back the other way and say if I start with this many atoms, I could figure out that that was 2.54 moles. Let's take a slightly more complicated example. It says how many carbon atoms are there if you have 0.350 moles of glucose. So how many carbon atoms are there in this many moles of the glucose molecule? In order to answer this question, I want to start with an analogy that might be a little simpler to understand. Let's say that you had 12 dozen bikes. I want to know how many wheels is that. How many wheels do you have? So I'll show you how this is an analogy to the above problem. A mole is just a number, just like a dozen. So we want to know how many wheels do you have if you have 12 dozen bikes. Well, we know our given is 12 dozen bikes. So I have to have dozen on the bottom. Well, I'm going to convert dozen to numbers of bikes. I know that 1 dozen bikes is 12 bikes. So I know I got 144 bikes here. Now we can go to wheels, because we know that 1 bike has 2 wheels. So that means I got 288 wheels. Now I'm not worried about sig figs here. 12 is an exact number, and I don't want to get too hung up on that. Well, I want to show you the analogy that this has to the above problems. Above problem. I don't have a dozen bikes, but I do have 0.350 moles. Of glucose. So remember, a dozen is just a number, and a mole is just a number. It's just a bigger number. So I'm going to go from moles to molecules. I know that 1 mole of glucose is 6.022 times 10 to the 23rd molecules of glucose. So I've converted moles to molecules. Now look at the analogy here. Here I had a dozen bikes. Dozen's just a number. I converted it to bikes. I have this many moles. I just converted it to molecules. It's like I know now how many molecules I have in that many moles. Just like I know how many bikes there were in that many dozen. So right now I'm in molecules of glucose. But I have to go to atoms, carbon atoms specifically. Well, here's what I know. I have molecules of glucose here, and I know that for every 1 molecule of glucose, there's 6 carbon atoms. So my molecules cancel. So just like 1 bike had 2 wheels, 1 molecule of glucose has 6 carbon atoms. So I have, if I have 0.35 moles of glucose, I have 1.26 times 10 to the 24th carbon atoms. (1.26 times 10 to the 24th carbon atoms). So that's how many carbon atoms there are in this many moles of glucose, just like there's this many wheels in 12 dozen. So the final thing I want to talk to you about is slide 8 here. We just talked about how a mole will allow you to convert to atoms or molecules. Well, what's also really neat about the mole is it can also allow you to go between moles and mass. So the mole relates not only to the number of atoms or molecules, but we can also convert that to grams. which is really important because that's what chemists do often, is they measure out amounts of things in a balance. So a mole is defined as the number of carbon atoms in exactly 12 grams of carbon-12. That's the definition of a mole. A mole is 6.022 times 10 to the 23rd of anything. Well, it turns out if you weigh out 12 grams, 12.000 forever grams of carbon-12, you will have 1 mole. So let's look at this. If you massed out 12 grams of carbon, you would have 1 mole of carbon. So a conversion factor that we could use here is that 12 grams, it's 12.000, but I'll just put 12 grams of carbon-12 is equivalent to 1 mole of carbon-12. So if I was to weigh out 12 grams of carbon-12, I'd have a mole, or in this 12 grams I would have 6.022 times 10 to the 23rd carbon-12 atoms. So 12 grams of this has that many carbon-12 atoms. And you'll see why this is a really important relationship later, so I'll talk about these last 2 bullets later on. What I want you to do for the next lecture is go to the videos material folder on Blackboard. After you go to the videos materials folder, go to the videos folder. And then look for the stoichiometry quiz. Stoichiometry video quiz. So that's, this is stoichiometry video quiz. So go to Blackboard and go to the following folders and bring that completed quiz to class next time. Remember, that's 10 points, so you probably really want to do this, and it'll help you understand what we're going to do in the next class.